Hi everyone, I am Dr.D.M.Swamy, working as Assistant Professor in Economics, Bijar Government Degree College, Narayana. Okay, today I want to discuss some important aspect, that is the diagrams and their importance and their importance in the statistics. Particularly today in the today class, I am going to focus on the bar diagram and pie diagram. So because already I discussed in the previous video class, that is what is the diagram and what is the differences between diagram and graph, and what are the advantages of the diagrams and what are the some limitations of the diagrams, and type of the diagrams like histogram, frequency polygon, and Woju curve. All these things already we discussed. The remaining types of the diagrams in the statistics are like bar diagram and pie diagrams are here. Okay, in this particular class, we will try to focus on the remaining two diagrams, that is bar diagram and what is called pie diagram. Okay, just for the sake of the continuation, these are the things already we discussed. So see, these are the what is called bar diagrams, and this is called pie diagram. Okay, these two things we are going to discuss in this particular class today. Okay, already in the previous video class I told you that pie diagram nothing but the pie diagram is in the circle manner. The area of the circle is equal to 360 degrees. The whatever the data we mobilize, that the total population of the data is equal to 360 degrees, which is equal to 100% in the mathematical expression. Okay, so based on the area in the circle, we can decide the contribution of that particular area or population and whatever. Okay, that is one type of the expression. Okay, in the bar diagram, that data going to be represents in the what is called rectangular shape. Of course, so the histograms are also there in the rectangular shape only, but the line diagram will be the in the line shape. Okay, so already also we discussed that what is the difference between bar diagram and histogram. Both are in the rectangular shape, but even though both are in the rectangular shape, the bar diagrams there is a the gap between one unit with another unit in the bar diagram, whereas there is no gap in between from one unit to another unit, one population to another population, one sector to another sector in the histogram. Okay, there should be continuous series or continuous will be there in the histograms, where there is a what is called bar diagram. We have the gap between one unit with another unit. Okay, when we are coming to this pie diagram, of course, this is the in the circle shape. We don't have any problem. Okay, so all these things already we discussed. What is diagram? How it is going to use that diagram in the statistics, and what are the advantages we have from these diagrams. All these advantages we have, and also we discussed what are the some important limitations we have in this when you are using these diagrammatic manners and extra, and this the graphic representation, that is the difference between a graphic and a diagram. So in this particular aspect we discussed the histogram, frequency polygon. So okay, histogram we discussed it. So like this is the shape of the histogram, there is no gap, and this is called polygon, frequency polygon. So here we are going to take the histogram only, but the mid values we are going to take from the histogram in each and every rectangular shape of the histogram. And also going to discuss of course this ogive curves, like greater than type of ogive curve, less than type of ogive curve. Okay, all these things okay, we'll discuss in the previous slides. Okay, now in this video class we will try to focus on the different the remaining diagrams which are left, that is bar diagram and pie diagram. So which are uses importance of this diagrams in the statistics. Okay, all these things we are going to be discussed today in the class. Okay, so already I told you that bar diagram is nothing but it is a rectangular shape. Okay, so when we are using the bar diagram for analyzing the data, when we are using this bar diagram, okay, definitely we there will be gap from one objective to another objective, or one variable to with another variable, or one sector to another sector, or one person to another person. There definitely there is a what is called a gap, what we can see. Okay, at the same time, when we are talking about this various type of this bar diagrams, we have the different categories. Okay, we have the different areas approach. Of course, we can see in this bar okay diagram. Okay, like they are called simple bar diagram. Okay, subdivided bar diagram, what is called percentage bar diagram. Okay, multiple bar diagram. Okay, like that is the pie diagram is different. Okay, so these are called what is called bar diagrams. Okay, this pie diagram is completely it is different. Okay, so these are the some important diagrams okay in this particular category. Okay, when we are talking about this simple bar diagram, okay, in case of the simple bar diagram, the vertical or horizontal bars with height proportional to the value of the item are constructed. Okay, whatever the values are there in the data, that values are representing in the height, what we can say. Okay, in the horizontal, so we are going to take the variables, for example age or height, so all these things. So how much age was there, that values, that is frequency, we can say in the statistical language. Okay, that frequency we can see in this particular aspect in the okay vertical aspect. Okay, the width of the bar is chosen arbitrarily and is kept constant for every bar. So here, see, when we are taking the horizontal bar, this is the illustration we are taking for the explanation. So we are going to take the equal width of this each and every bar from one to another one. What you can say. Okay, like okay, the different bars are drawn so that the gap between the successive bars is the same. So the successive bar, the area, the width of the each and every the bar will be equal when we are talking about this one. Okay, the bar diagrams are particularly suitable for presenting the individual series. Okay, such as time and spatial series. Okay, for the individual series, we can say we can use the a simple bar diagram. Okay, it is very suitable the diagram. So because why this is important? No, in the individual series we have the x values and we have only x values. Sorry. We have only x values will be there. So that's why since only the x values will be there, there is no comparison, there is no yeah, other things will be there. We can use the in the simple diagram directly. Okay, x is this much. Okay, why this much? Okay, like we can use this simple bar diagram. Okay, this is okay. So simple bar chart we can see in 2011. In 2011, X is having something, the B having something, and C having something. Like in 2012, so X, B, X, Y, X or Y or Z will be like this. Like in 2013, 14, like that. Every year we can see. Okay, in this particular year, so this value will be like this. So each and every value is different. Okay, they are not at all related to with X with Y. Okay, this okay simple diagram or the simple bar chart. Okay, always we can see like this for the okay explanation. Okay, that is one category. And uh, after this simple bar diagram, the next one is subdivided bar diagrams. Okay, there are four the bar diagrams like simple bar diagram, subdivided bar diagrams, percentage bar diagram, okay, multiple bar diagram and all. So this simple divided bar diagram is one of the bar diagram. So in this subdivided bar diagram, we are going to study of sub classification of the phenomena. Okay, so in the simple bar diagram, there is no sub classification. Directly, we are going to take the extreme values, but here we are going to take the sub values. Okay, sub classification phenomena can be done by the using subdivided bar diagram. Okay, see for example, the total agriculture sector growth rate 4%. This is an extreme value. We can see in the simple bar diagram. But within this year, the first quarter growth rate, second quarter growth rate, third quarter growth rate, like that, we can take this sub classification in this subdivided bar diagram. Okay, corresponding to each sub category of the data, the bar is divided and what is called shaded. Okay, so to easily understanding, okay, the first quarter we can have the black color, the second quarter we have some other color, and third quarter. So just to understand the data wise, we are going to explain all these things. Okay, like this. Okay, like there will be as many shades as there will be sub portion each and every group. So each and every group there will be subgroups. So the subshades will be there to easily understand. The portion of the bar occupied by each subclass reflects the proportion of the total. So already I told you. Okay, so suppose the agriculture growth rate for a particular year is 4%. Okay, so in the first quarter 2%. So the 2% is the part of the total. Okay, so like that. So we can use that was. So the subclass reflects is the portion of the total one. Okay, so it is the part and parcel of the total one. So this is the subset of the total thing. For what for that we can use okay this particular aspect. Okay, in addition to the general rules for constructing the bar diagrams, the following subdivided or components the bar diagrams, we are going to use some following things. Okay, these following things we are going to be used for that classification. Okay, anyway, so here the subdivided bar diagram, so like this. Okay, see for example in 2011-12 the total number of students registered are in the different subjects. Okay, in the particular college, total students are 100 students. That is the extreme value we can see in the simple bar diagram. But out of this 100, some percentage people are history, some percentage people belongs to economics, some percentage people are belongs to statistics. So here, see the this part, this portion is history, this portion is economics. Okay, this portion is statistics. Take for example around 20 percentage 22 percentage are statistics students are there. So here almost this 22 60 of course nothing but 40. So 40 students from economic students. So this take example, this is 60 to 100 again the 40 students from the So the for 40% students from history, 40 students from the economics, okay, for 20 students from the statistics, total 100%. So like that we can use. So that's why each and every subset we are going to use in the different shades or different colors. Okay, this is a history. The vertical lines are called for the history students. The white color area is shows the economics. So this cross lines area is explain the statistics. We can use other colors. For example, if this is the red color, okay, this is the black color, this is the blue color. So that means blue color represent the history. This black color represent the economics, or red colors represent the statistics. Okay, like that we can see in the different way. Okay, that is what is called subdivided the bar diagram along with what is called simple bar diagram. Okay, along with the simple bar diagram and subdivided bar diagram, the another category in the bar diagram is called what is called percentage bar diagram. Okay, percentage bar diagram, of course it is also look like a subdivided bar diagram with the little bit difference. Okay, in this diagram the total length of the bar is taken as 100. Okay, when you are so because it is going to one bar is considered as 100% automatically. Okay, 100%. Okay, in this method the components parts are expressed as the percentage of the total, and a component bar diagram is drawn with all the bars having the equal length. So the equal length with equal length we can see, and sub components we can see the percentage how much they are there in this total group. Okay, this percentage of bar diagrams, okay, the percentage of the bar diagrams are useful to present the relevant changes in the data. Okay, whenever the data changes, so to explain that relevant data, this bar diagram, this percentage bar diagram using very easy and very okay important. Okay, what we can see in this one, like subdivided bar diagrams presented graphically on percentage basis gives percentage bar diagram. So already I told you, almost it is look like a subdivided bar diagram. These subdivided bar diagrams will explain the absolute values unread. Okay, so but in the bar percentage diagram that is going to explain in the percentage. Okay, so that is the little bit what is called differences between so this one and that one, what we can say. Okay, this is okay, like what is called percentage bar diagram. See, in the both cases, so the equal bars is equal to 100 days. So here the percentage we are going to be explained. So 35% belongs to history in 2016-17. 40% belongs to economics, or 25% belongs to statistics, like that. So in the 2017-18, okay, 30% belongs to statistics, 42% is related to what is called economics, 28% belongs to history. Okay, from 2016-17 to 2017-18, the number of enrollment students in the different subjects were changed like this. For example, in the statistics, it was increased from 25% to 30%. That means 5% it was increased. Even the in the economics also the enrollment of the students was increased from 40% to 42%. That means 2% was increased. But when you come to the history, 2016-17, 35 students were enrolled. But now in 2017-18, only 28% students were enrolled. That means comparatively, the history enrollment in the economics and statistics was increased, but the enrollment in the history was declined. So that we can see. Okay, that is the thing we can see. We can explain by observing this particular what is called aspect. Okay, here particularly again we can also take in consideration that the highest number of the students enrollment was increased in the statistics. So percentage. So it was increased to 5% in the statistics, but in economics it was increased only what is called 2%. So like that, how it was changing and what aspect is more changing, what declining, how much it is declining. So all the things we can see in the percentage okay, bar diagram. So otherwise it is looking like a subdivided bar diagram only. So but the subdivided bar diagram are explaining in the percentage. So that's why it is called percentage, what is called bar diagram, what we can say, okay, in this particular cases. Okay, that is one thing. And the next one is a multiple bar diagram. So there are four type of bar diagrams. So what is like a simple bar diagram, subdivided bar diagram, percentage bar diagram, and another one is a multiple bar diagram. Okay, when we are drawing the multiple diagram, okay, when we are going to draw the multiple diagram, this multiple diagram is used when comparison are to be shown between two or more sets of the interrelated phenomena or variables. Okay, within the same area, if we have some objectives uh, to comparison between this interrelated phenomenon, we are going to use this multiple bar okay, diagram. Like it is a set of bars for person, place, or frequency related to phenomena are known side by side without any gap. Okay, whenever we are discussing this set of the bars for the person, it may be person, it may be place, it may be frequency, whatever it may be, related to same phenomena. So are going to draw side by side without any gap. So there should not be any gap related to the same phenomena, same character, same person, or same place. Okay, that we can see in this particular okay, diagram or which is known as the multiple diagram, we can say. Okay, so in the simple bar diagram, we have only one. In the subdivided, of course, we have one, there is a gap. In the simple bar diagram also there will be gap. Okay, in the subdivided group also there is a gap. In the percentage also there is a gap. But in the multiple bar diagram, there is a gap between one variable and a variable. But within the same variable, if there is any interlinkages, for that we are going to draw one more bar without gap. Okay, that is what you can see. Okay, this the distinguish between the different bars in the set, different colored shades are being used for easily understanding. We are going to use okay, so, suppose like this. So average weekly network load in the server 1, server 2, server 3, like that. So Monday, the server 1 is having this 100% network, server 2 having around 80% network, and server 3 is having this 100% network. Okay, when come to this Tuesday, server 1 is having around 140% megabytes network, but server 2 having more one. So like that we can see the same the systems, the three systems we consider here. The three systems are uh, taking in the different way. For example, we are going to estimate, we are going to explain uh, three people weekly works in the multiple bar diagram. Okay, in the first day, A work or output, B work output, C work output, we can see. And in the Tuesday, the B output may be more than the A or C. In the Wednesday, C output may be more than the A and B. In the Thursday, the A output may be more than, like because based on that particular day, is health condition, is work mentality, availability of the tools, all these things are going to be decided. Okay, they are going to be decided for this particular purpose. So like for each and everything we are going to be colored in different shades like this only. Okay, that is called bar diagram. So like the simple, the subdivided, the percentage bar diagrams, and what is called multiple bar diagrams. All these type of the bar diagrams will going to be used for the individual series particularly. Uh, okay, like uh, after this, what is called the bar diagram. The next type of the diagram is called pie diagram. Okay, so already I told you the pie diagram is nothing but okay, that will be in the circular manner. Okay, it is also known as the angular diagram. Okay, this pie diagram is called circular manner. Since it was there in the circular manner, it was called angular diagram because the circular shape of the pie diagram explaining the angle position. Okay, a pie chart or diagram is a circle divided into different component sectors corresponding to the frequencies of the variables in that distribution. Okay, based on the availability of the distribution, we are going to be divided into sub components. So out of the total population, 50% people are having the same character. So 180 degrees area, like that we are going to be divided. Okay, a circle, what is called a circle represent 360. So already I told you a circle, the area of the circle is called 360 degrees. So 360 angle is divided in proportion to percentage. So the circle is 360 degrees. Suppose 180 degrees area was covered the particular aspect. So that is nothing but 50% area in the circle was considered. Okay, 90 degrees the area was considered. So 45%, like that we can see. What we can say? Okay, I'm sorry, 25% we can see. Okay, 25% is nothing but so 45 that is 90 degrees, what you can say. Okay, this degree is represented by the various components parts of given magnitude can be obtained by using this formula. So the different this formula, whatever I told you, based on that formula we are going to subdivide into different components. A pie diagram therefore is a circle. It was subdivided into component sectors to present the proportion of the different constants parts to the total. Okay, for the total we are going to divide subgroup based on their volume or value or frequency or percentage. So a such pie diagram is also known as the percentage terms. Okay, so all these things we are going to explain in the what is called percentage terms. So in percentage terms we are explaining. We are explaining in this percentage terms. What we can say. Look here, how these pie diagrams are going to be constructed. Okay, what are the steps are required to construct the pie diagrams? Okay, we will try to understand. Okay, this construction of the pie diagrams requires the following things. Okay, like okay, what are the things are required? So these are the things. The total of all categories or components or groups. Okay, first of all, before going to draw this pie diagram, find the value of each category and component or group as a percentage. Percentage of total of all categories or components of the groups. So total, how much population was there, and out of that one, so each and every component, how much it was there. So that value should be converted into what is called a percentage. Okay, the based on that percentage we are going for this what is called we have to write in the degrees. Okay, the second, the calculate the corresponding angle for an item by following the angle for the formula. So this is angle for an item. Value of the item, how much value was there, and the total value of the items into 360 degrees. Okay, for example, so okay, take example. The value of the certain things is called like 50. Okay, so or 60. Okay, the total value of that one is 150, for example. So then here we are going to write like this: the 60. Okay, of course, so 60 divided by 150, what is called, into 360, because it is converting into 360s. Okay, based on this, we are going to take how much the angle it was there. Okay, and for the take of a circle of a suitable size and draw radius. Okay, in the radius manner, we have to write in the circular manner. Now draw angle calculated in step 2. For example, this may be just approximately, I am saying 180 is equal to 50%. So this is like around 160, maybe around 160 degrees. Let's example. Okay, so based on the in the circle manner, we have to take 160 degrees. Now draw angle calculated step 2, that is 160 degrees, with the help of the protractor, which are going to use in the COMBOX in the mathematical geometrics. Okay, shade or a color different segments suitably or make the distinctions. So like that, we have to calculate each and everything, and we have to demarcate, and we have to color it for the next proportionate. And so the between different categories or components of the groups also we have to, okay, take the consideration. And for each category or component or group, put the percentage, so that should be converted into the percentage. Okay, in the we have to convert it into the, okay, percentage manner. So like that, we have to draw this pie diagram. So for example, so take example, number of items sold in each and every day. Okay, that is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So suppose 100 commodities are there, or 200 commodities are there. So in Monday, out of 242 commodities were sold. So the 42 divided by 200 into 360. So nothing but you will get a 21 angle. So if you convert it into the percentage also, we can say the 21 percentage. So like that, so we are going to be calculated so for each and every aspect in this pie diagram. So this is called a pie diagram. So like that, for easily explanation, we are going to using all these type of the, okay, diagrams for the statistical analysis or conclusion. Okay, this is what we can observe in this particular diagrammatic representation. Okay, thank you.